So first thing, before going into the descriptive statistics, first let me discuss about the data. So sometimes we call that collection of information is data, and this data may be represented in different form, maybe in tabular forms and in the form of graphics, graphs, and there are some basic statistics to get the information from the data. So we will be discussing one by one here. What comes in descriptive statistics? Basically, there are four features of a distribution, four basic features of a distribution. One is measure of central tendency, another one is measure of dispersion, third one is a measure of skewness.
The slides are not getting changed. Slides are not getting changed. No, sir. It is not moving.
No,
only first slide.
I am not moving right now. I am
okay,
not
sir.
See whether it is moving.
Now it is. Yes, working.
Yeah. So I am just discussing the things. I am trying to start the things. So I am not moving the slide.
Okay, sir. Thank you.
So there are four features we will be discussing, and so the whole distribution, probability distribution is, described by these four features. One is measure of central tendency, another one is measure of dispersion, third one is measure of skewness, and fourth one is measure of kurtosis. So all four features we will be discussing, and these makes the descriptive statistics. So descriptive statistics that summarizes or describe the important characteristics, and there are four characteristics of the data set, say mean, standard deviation, skewness, and kurtosis, etc. The characteristics of the data, see here, center means measure of dispersion, measure of, see, this is measure of skewness, this is measure of dispersion, and two more are skewness and kurtosis, and then the distribution and outliers. These are basic characteristics which we have to keep in mind while doing the statistical analysis. So now come to measure of central tendency, the value at the center or middle of the data set. See, every data has a tendency to move towards the central value. This tendency of the data is known as central tendency. And the measures which measure this tendency are known as measures of central tendency. And these measures are mean, median, mode, quartile, decile, percentile. And further, mean is of three types: arithmetic mean, geometric mean, and harmonic mean. These are some notations we know that these are usual notation. This sigma denotes the sum, x as a variable, n number of values in a sample, that is sample size, and capital N represents the population size. Now come to arithmetic mean. Arithmetic mean is simply the addition of the numbers divided by the number. Addition of the values of the variable and divided by their numbers. And see, this arithmetic mean is the best measure of central tendency for the homogeneous data only. If the data is not homogeneous, this is not going to be a very good measure of central tendency, because the arithmetic mean is badly affected by the extreme observations. If some outliers or extreme observations are present in the data, then arithmetic mean may mislead the representation or may mislead us from the actual central tendency measure. Suppose, for example, if in a class of, say, students, a very little kid is included into the class, then, and we are measuring the average height of the class, then the height will be reduced, because that kid is outlier for that class. And suppose the person like Amitabh Bachchan say or Khali, with a very big height, is included in the class, then it will increase the average height of the class. So these are the outliers or extreme observations for the data. And whenever, and this, if you will represent it in a graph, then it will be a skewed distribution. So when it is not similar distribution, when it is skewed distribution, then arithmetic doesn't play a very good role as the measure of central tendency. So in that situation, we will search for some robust measure, and median is one of them. We will be discussing later. So this is basic formula for arithmetic mean, that is sum of the numbers, sum of the observations divided by the number. And what are the advantages? That it is, mathematically it is very strong, and we can calculate, and we can further use for future observations as well. So sample mean drawn from the same population tends to vary less than other measures of central tendency. If the data is homogeneous, we must add that one. Takes every data value into the account. This is very good feature of it, that it uses every observation of the data. But the disadvantage is that it is very sensitive to every data value. One extreme value can affect it dramatically. So is not a resistant measure of the central tendency when the outliers or extreme observations are present in the data, and they are so important that even we cannot exclude them from the analysis. Otherwise, generally, extreme observations are outliers. If they are not important, then they are excluded from the data. But suppose if they are important, suppose we are taking the blood pressures of the persons admitted in a hospital. So what doctor see the measure of their blood pressures, but if a person is getting very high blood pressure, so it will be a outlier among the patients, but we have to take, our doctor have to take the special care of that person. We cannot exclude it from the analysis. So in that situation, we will use some robust measures like median. So this is the formula to calculate the mean of the given observations. Here we have given these 5 observations. So add this one. So this is the average value of the variable under consideration. Now come to median. See, the geometric mean and harmonic means are used for skewed data, and basically they are used for the calculation of the rates and ratios. If you are calculating, that is why when suppose we generally face a question in 10th standard, say that a person travel a particular distance in that time with this particular speed, then next it is 5 kilometers with this speed, and then next 6 kilometers with this speed. What is the average speed of the person? So there we cannot apply this arithmetic mean. So here there we are calculating the rate. So there harmonic mean will be applied. Similarly, while making the index numbers, so index number shows the change in between a particular time, one base year and another one is current year. So this is measuring the change. So there we apply the geometric mean. See, there is a minute difference between using the geometric mean and harmonic mean. Both measures the change and rates. But if the change is per unit, then harmonic mean is applied. Otherwise, geometric mean is applied. Per unit, the speed per hour. That is why in that case, in speed and that average speed, to get average speed, we use the harmonic mean. Wages per day, work per hour. So this in this situation, we will use the harmonic mean. So now come to median. If the data is say skewed, it is having some extreme observations. So median is not affected by the extreme observations. It only counts the numbers below that and above that. So 50% of the observations below median and 50% of the above.
Sir,
So the
data is skewed. Sorry to disturb, sir. Sir, data is skewed means when we
outliers
have.
are there. See, let me put some graph to show you the. If you are not waiting till that, so let me go to the graph. See, this is the skewed data. This is symmetric data. All 3 points are symmetric here. But this is skewed by that it is making tail on one side. So since it is making a tail on right side, so this is a positively skewed data and it is making a tail on left side. So it is negatively skewed data. See how this will be found. Suppose some average marks are obtained by the most of the students, but some of them are obtaining very high marks, say 90, 95, 80, and the average is 55, 56 to 60. Then this will be positively skewed. And here some students are getting average marks, say, and some of them are failed, say very low marks. So this will be case of negative. Okay, now come to median. So the middle value, when the original data values are arranged in order of increasing or decreasing, we know. But basically median is used where the data is skewed. It means outliers and extreme observations are present in the data and we are not excluding while at the stage of cleaning the data. So often denoted by X curly bar, pronounced as X tilde. This is X tilde. So is not affected by the extreme value. See here, is a resistant measure of the central tendency. So this is a robust measure for measuring the central tendency of the data in hand when the data is skewed or say not symmetric. How to find the median, we know.
Sir, what is robust measure?
Robust means which is not affected by extreme observations. If it is affected, then it is not robust. Strong, hefty. So if outliers are present there, they are not affecting that. If any mathematical formula, say, or any observation is not deviated very much by the extreme values, then this is known as the robust measure.
Thank you, sir.
So how to find the median? We know that either we have to arrange it in ascending order or descending order, and we see if the numbers of values are odd or even. This is for the ungrouped data case. There are two types of data. One is ungrouped data case, means the data is in numbers, and if it is repeated, then with the frequency. And if we have arranged the data, large data, in terms of intervals, class intervals, then this is known as group. So it is ungrouped data case. We have arranged it in ascending order and see the number of observations are 1, 2, 3, 4, 5, 6, and 7. If odd numbers are there, then the formula is n plus 1 upon 2th term. So here it is 7 plus 1, 8 by 2 means 4th term. So 1, 2, 3, 4th term. So median is 0.73 here. Now come to for the even case. So here we have 6 observations. Now we have put them in ascending order. Now 6 means the formula for the median is n by 2th term plus n by 2th plus 1th term. So here it is 6. So 6 by 2, that third term plus 4th term divided by 2. So third term is 0.73, 4th term is 1.1 and divided by the 2. So the median is 0.915. This is the case for the ungrouped data. Now come to calculate the median for the group data case. So group data means it is arranged in terms of class intervals. So here class intervals are there. These are class intervals. And you can see here, these are the frequency. Frequency means well, there is one observation which is getting, say, marks in between 60 to 62. There are 3 persons, we lie between 63 to 65, 3, 66 to 68. So this way we can calculate this. We can make this chart, this table. Now we make a cumulative frequency table. We start adding 1, then add this 1 to 3, 4, 4 to 3, 7, 7 to 4.
हाँ
So this way we can
नहीं तो
this cumulative frequency.
चाय बना दूं?
Now since we are calculating the median, please you are requested to put your mic off.
Oh, sorry.
So if now since we are calculating the median, so median is a single point which divides the whole distribution in 2 equal parts. So we will take n by 2 and we'll see this n by 2 is lying in which cumulative frequency. So n by 2 is 15. So it is lying in this 16. So this will be the median frequency and this will be the median class. And the formula is that L1 plus L. This
Sir, please.
L1 plus L2 minus L1 or n by 2 minus C upon F. So this way you have to, this L means lower class of the median class, lower value, and upper value of the median class. So this I is nothing but it is L2 minus L1, means the difference of the two. So 74 minus 72, that is 2. So just put here 74 minus 72, it is 2, not 3. I is 3. No, I is 2. So you make it correct. So L1, your L1 is this 72. So this way you have to calculate the formula. You have to make the corrections in this formula. This is not the correct value. Actually.
Sir, can you please explain it again?
See,
And sir, where do we get this frequency, like this tape, like?
Frequency will be given. You will
Okay.
see. You will see from the data. You have to make that the whole data is given to you. Then you have to arrange it in class intervals. So you will get the frequency. How many persons are lying in between intervals? So this way only you have to make the cumulative frequency less than type, and then you make n by 2 where it is lying in cumulative frequency. The corresponding frequency will be the median frequency. This will be the median class, and this 21 will be the C, that is F2. So what we have to do now, we have to use the formula L1 plus L2 minus L1 upon F n by 2 minus C. So we have to make the correction here. Some other.
So please explain, sir, why F2 is 11?
Why?
Why F2 is 11?
Not F2. Yeah. You don't go on these values. These are not given correctly.
Okay, sir.
I have taken this image from the Google, but this is not correct. So tomorrow we'll be doing it correctly.
Okay, sir.
While hands on. It is not. Okay. Let me see. It is 11 correctly because it is given from lower side to upper side, and generally we make from upper side to lower side. So C will be this 11 before that frequency. So now, and your median class is 72 to 74. This is F and this is C. So now we will use the formula L1 plus L2 minus L1 upon F n by 2 minus C. So actually this will be that. Now come to mode. We know that mode is nothing but the value with the highest frequency is known as mode. And so we will be calculating it for the ungrouped data as well as for the group data case. So here you can see that and it will be more one mode, the frequency or distribution with one mode. It may be bimodal, it may be multimodal. If it is having some peaks, then it will be multimodal. See here, we have seen that the frequency here mode is 1.1 because it has comes 2 times. And here 27, 27, 27, 55, 55, 55, and 88, 88, 90. So 27 and 55, there are 2 modes, 27 and 45. And see here, it is having no mode because there is no repetition of any numbers. Now this is for the group data case. By the same fashion, we will make that cumulative frequency and that one. And not cumulative frequency, we will see only, see here, let me explain through this table. This is the class interval, these are the frequencies. See here, which one is having maximum frequency, that is 25. So this will be the model class and this will be F1, this will be 21, 19 will be F2. So we have to this formula. And this 25 is F naught.
The maximum frequency is 29, I think. 41.
Okay, yeah, it is 29. So here this is maximum one, and we will be using as this one as F2. And here F1, F2 is not given. Actually, this is F naught and this is F1. And that will be the open class for the next one. So this one, this way we can calculate. Actually, this will be the modal class. This is the modal frequency. And before that, it is F1 and F2 is missing here. So we'll put it at 0. So, so we will calculate it through that. So L1 is 41. Put here at 41. F naught is up 29. F1 is 19. And F naught is again 29. F1 is 19. Plus F naught is 29. And F2 we can put here 0. And C, that is L2 minus L1 here. So that is 9 actually, 50 minus 21. So this way we can calculate the mode for the frequency group data. Now mid-range, we know maximum plus minimum divided by 2. So we can calculate very easily. Now come to measure of dispersion, that is variation. So we know that the GS1 is range, that is maximum minus minimum. But it is not very much informative because here we are using only 2 observations, maximum one and minimum one. But the measure is good, considered good, which uses the all observations. Now come to standard deviation, we know. Before that, we calculate the variance, or we first calculate the standard deviation and get it squared, then you will get the variance. So what we see that we take the deviations from the mean and get it squared, because if we are not getting it squared, there is property of mean that sum of deviation about mean is 0. So it will be 0. That is why we get the square of that and take the square root of that. This is known as the standard deviation. If we take the square of that, then that is the variance. See.
Excuse me, sir.
Yeah.
Sir, what is the difference between standard deviation and variance?
Variance.
What does it present according to sample, sir?
Actually, there is need of standard deviation. But if we take the deviations from the mean and we calculate its mean, then we get 0. Because of the property of mean that sum of deviation about mean is 0. So what to do? We take the mod of that and we calculate the mean deviation actually. But mean deviation is not true representative of that, because every negative observation is also positive and we are taking the mean of that. So it is shifting towards positive direction. So what we do, we take the squares of the deviations and get the mean of that, and that is known as variance. But the measure of that is different from the mean actual observation. Suppose we are considering the average height of the persons, but we are calculating the variance of that height. So the measure of variance will be height square, meter square. And while we are taking the measures in meter, so how will we put it that the average height of this class is that and variance is that meter square? So that
Sir,
is why to make the same measure, we take the square root of that, and that is standard deviation.
Sorry to interrupt, sir. I'm asking, just say, for example, you take example of average height. So if we take mean represents like average height means a middle value that present the whole data. And what according to standard deviation and variance, what does it represent according to data?
It represents the dispersion from the mean towards both sides of the data.
Okay,
There is a
sir.
central point, that is mean. So how much it is, the values may deviate from that mean towards positive as well as toward the negative direction. This
So both
represents
standard
the
deviation and
standard deviation and variance both represent the scatteredness of the observation
scatteredness.
around the mean.
Okay.
It
Okay, sir.
represents the scatteredness of the observations around the mean.
Thank you, sir.
So these are some notations. So here we can calculate this standard deviation this way. And okay, now to okay, these are some properties for the distribution. I am not going into detail that it represents the 65% of the data, then almost 90% of the data, and that is one beautiful property of the normal distribution area property, that mu plus minus 3 sigma represents the 99.73% of the area, and it represents almost 90% of the data. So I'm not going into the detail because we are just discussing here the descriptive statistics only. So we should skip it. Now there is a very useful, relative measure. Sometimes we come across the problem that suppose there are two factories. The one factory is producing some average of a product and with a variation, and some another factory is producing some different average and some different variation. Suppose one is having larger mean and lesser variance, and another one is having lesser mean and larger variance. So how to compare the two and how to decide which one is good one? So there we use this coefficient of variation, that is a relative measure. And one more thing, even if the two measures are in different measurements, we can compare them because this coefficient of variation is a relative measure. It is a pure number. So it is nothing but it is standard deviation divided by the mean, and we can represent it in terms of percentage. So multiply with 100, then it will be presented in the number percentage. So the system or the say factory or any system with the lesser coefficient of variation is supposed to be good.
Sir, I
excuse me,
I
I
want
have a doubt.
one question.
Sir, I want to ask
you
about
see-
the formula of the standard deviation.
See, standard deviation is nothing but it is square root of the variance. The formula is
Sir, in the denominator we use n and sometimes we use n minus 1.
yeah.
So
N minus 1 is mostly used because it represents it is the unbiased, for the sample only we use N minus 1 because it is the unbiased estimate of the population variance. If you are not using N minus 1, then it is not going to be unbiased of that.
Sir, it is like if the number of observation is less than 30, we use n minus 1, is it that?
No, if it is more than that, then it will not impact that. So every time we should use N minus 1 if we are taking the sample variance, because it is unbiased for the population.
Sir, is there any difference in the value of the variance between the between the population and the sample?
Pardon, you make clear because your voice is not clear.
Sir, is there any difference in the value of the standard deviation for mean for the population and the sample?
It depends on that formula. Mean sample we are using a part of that, and for the population if you are calculating, then it is a parameter. So parameter is estimated by the sample only. If you are using for the population, there is no need of sample because that represents the true population parameter. See, we do the sampling only when we are not doing complete enumeration. That is census. If you are doing census, then there is no need of sampling. But if you wish the estimate of that population parameter in less effort, less time, less money, less manpower, then we do the sampling. Let me finish. You all are requested to note down the questions and I will be entertaining every question. So first, let me finish. You just not note down the even the question as well as if you can see then the slide number or thing. So now this we know the percentile. So percentile, similarly decile, percentile, we can calculate decile, percentile, quartile as well. So percentile are nothing but these are the 99 points which divide the whole distribution in 100 equal parts. Similarly, quartiles are the 3 points which divide the whole distribution in 4 equal parts. And the decile are the 9 points which divide the whole distribution in 100 equal parts. So we have to see all the, we can calculate all decile, percentile, quartiles in the same fashion as we calculate the median because median is the second quartile. So this way we can calculate, we will see the quartile. If we are calculating the percentile, then we will see where the particular quartile is lying in which class interval, and that way we can calculate the quartile. That is percentile. Maybe percentile, maybe quartile, maybe decile. So everything we can calculate. We know that Q1 first quartile represents 25% of the observation. Q2, that is median, represents the 50% of the data, and third quartile represents the 75% of the data. So this way we can calculate and see every quartile class in first quartile class interval will be different, second quartile class interval will be different, and third quartile limit will be different. So this way every time we have to calculate, we have to see where n by 4 or 2n by 4 or 3n by 4 is lying in the cumulative data. So this way you can see 25% of the data. These are some other statistics, that is quartile, interquartile range, semi-quartile range, and mid-quartile, and this way, this is the percentile range. Now come to measure of skewness as well as measure of kurtosis. So here see, we see the symmetricity and the measure of skewness are, there are two measures mathematically, they are calculated at beta 1 and gamma 1. So beta is nothing but for these all four characteristics, we calculate the 4 moments. Here we are not going to discuss the moment, but moments are not, these are the means of the powers of the deviation from the mean. These are the moments. So first, second, third, fourth moment, we have 4 moments, and these 4 characteristics are calculated by the 4 moments. That is why we calculate only 4 moments. So first, raw moment, there are 2 types of moment, raw moment and the moment about mean. Sometimes raw moment is also known as moment about origin. So first raw moment represents the measure of central tendency. Second central moment represents the measure of dispersion. Third central moment represents the measure of skewness, and fourth central moment represents the measure of kurtosis. So this way we can calculate all 4 features of the distribution. See here, this gives the measure skewness. So here see, if beta is equal to 0, it is symmetric. If it is greater than 0, then it is positively skewed, and if it is less than 0, then it is negatively skewed. So this way we can see by calculating beta 1, and that is mu3 square upon mu2 cube. That uses 2 moments, central moments, third and the second. This uses the fourth and second one. So beta 2 is nothing but it is mu4 upon mu2 square. See, if beta 2 is greater than equal to 3, then it is normal distribution, symmetric. And if it is if beta 2 is greater than 3, then it is positive kurtosis. It is, see, these three have special names. This is known as platykurtic, this is known as mesokurtic, this is known as leptokurtic. So if beta 2 is greater than 3, it is leptokurtic. If it is equal to 3, it is mesokurtic or normal. And if it is less than 3, then it is platykurtic, negative kurtosis. Now there are some graphs which are being used in descriptive statistics while doing descriptive statistical analysis. This is the dot plot we know, that is scatter plot. We can plot as well. For unidimensional and for two-dimensional, we can use it as well. That is known as scatter plot. See, this is the pie diagram, and pie diagram is used only for a single variable having different portions. Say the marks of the class are divided in different, say, percentage. First class, second class, third class, honors, this way. Or suppose a player is making, say, runs in different areas, leg off, leg on, back side, straight. This way we can represent the distribution of the observations of a single variable is represented in the form of pie diagram.
Sir, could you describe dot plot again?
Yeah. Pardon?
Describe the dot plot, the previous slide. Yes, dot plot.
Yeah. Dot plot, see, number of observations, this will show the frequency actually. It means, suppose 80 marks are having there are 3 persons having 80 marks, if it is IQ score. So this will represent the frequency only. Now come to bar chart. It is for the ungrouped data case. We have a frequency and we have a single point data. So in 2005, 2006, 2007, 2000, these are the years. And so there is a difference in histogram and bar chart. Bar charts are bars at the single points, not an interval. So far, it is for the ungrouped data case. So and these are the frequencies. And but that histogram is for the adjacent class intervals. Now come to stem and leaf. It is very old type of graphical representation of the data. See here, this is the stem and these are the leaves. So 5 is basic and then 6 is, it means 50. So we may represent, put comma here. So 5 is basic number, then 0, comma 6, comma this way. It means it is, the number is 50 and 56. So 5 is common at the 10th place, say, and then these are the leaves. Similarly, this is say 7. So the number are 70, 72, 73, 74, 75, 76, 76, 76, 76, many times 76. So this you have to represent this way. So these are the 10th and 100 points, and these are the ones. So you can represent this is the stem and this is the leaf. So this way we can see how many numbers in, say, tens are there, and these are the hundreds. So this way we can see the numbers in stem and leaf diagram. Histogram, we know that this represents the adjacent bars for the group data case with having the class intervals. See here, these are the class intervals and these are the corresponding frequencies. So we can have adjacent bars. This is known as the histogram. Now, if we are joining the midpoints of the class intervals through the scale, this is known as frequency polygon. And if you are just joining these midpoints through the freehand, then this is known as frequency curve. This is the percentage representation of the histogram. Now come to box plot. It is very important because it gives the idea of outlier stream observations. So here these are the whiskers and every represents say 50%, 50%, 50%, 50%. This is the median. This is first quartile. This is second quartile. It is little bit positively skewed data because at right side it is having more observations. You can see, have an idea. And see, this is the quartile deviation Q3 minus Q1. This is known as quartile deviation. If any point is lying 1.5 times the quartile deviation from this median, then it is supposed to be the outlier. And if it is 3 times distant from this point, then it is known as the extreme observation. See here. Normal distribution. So every this part will be symmetric to this one to this one, and this is the median of that. If it is asymmetric, then one whisker will be larger than the another one. See here, this is the positively skewed. See here, this is very high observation, and these are the very close observation. Then this is very high. So this whisker is very high. So median will be shifted towards maximum of the observations because it is not affected by the extreme observation. An outlier is a value that lies very far away from the vast majority of the other values in the data. These are some principles regarding outliers, that an outlier can have a dramatic effect on the mean and the standard deviation. We know because mean is affected by the extreme observation. An outlier can have a dramatic effect on the scale of the histogram, so that the true nature of the distribution is totally skewed. So in that case, we use the robust measure, and median is that, and for the dispersion, we use the mean deviation rather than standard deviation. So these are the graphs which we have discussed today. Now, if you have any query, any question, please ask.